All right, so I'm Anders Kristiansen. I work for Nethermind on Ethereum core. I'm here to talk a bit about the future of Ethereum. So I think there's a lot of complaints, reasonable complaints, and we have a pretty big problem in general from the foundation point of view and us as protocol developers, that we suck at marketing, and we are very bad actually at telling people, letting people know what we're doing, what is coming, and actually we are listening to community. We know there are issues, and we are working on them. So I think the number one people always complain about is gas prices, scaling. It's slow, too expensive, and we have for a long time been really sluggish on that part and focused maybe a bit too much on L2s, but we are turning that around now, and I will get back to that in just a moment. Then we have the rollups, so we have the rollup-centric roadmap. And that's the primary way if we want to scale Ethereum. However, rollups do have some issues. So right now we have basically all these isolated islands of different rollups that find it really hard to actually communicate with each other, which creates a lot of liquidity fragmentation, capital inefficiency, because it's difficult to move across these layers. And then there's also a problem, inherent problem in rollups today, that it's basically impossible to create a decentralized rollup, in that any rollup inherently depends on something we call a security council for upgrades. And basically, the problem is that a rollup typically tries to be EVM compatible, but the EVM continually evolves over time. That means the rollup also has to evolve, but who gets to say when the rollup upgrades? And that's why we have security councils, so you can upgrade the rollup and move forward and so on. And then, of course, also the price. So price action has been pretty bad this cycle. But I'm sure at the end of this presentation, Ethereum is going to pump and Solana is going to dump. Okay, so like I said, we suck at marketing. And Justin Drake, he's a great guy. He's a phenomenal researcher, but his marketing skills could be polished a bit. So you've probably seen this quite a bit. This messaging that we have, basically for quite a few years now, we've been saying L1, not for users, that's for institutions and rich people. This is a terrible message. We realize that. And quite recently, we have been pivoting, and now we are focusing back on the L1, and actually we want to scale now and be committed to it and actually do something about it. But first of all, I just want to touch briefly on why is it that it's so hard to scale. So you're probably familiar with the trilemma, that we have the triangle with the axis of scalability, security, and decentralization, and you can generally optimize for two of them at the cost of the other. So Ethereum exists at the security decentralization point and sacrificing scalability, and we do that because we value decentralization and security higher than scalability. So the problem for us is, how do we then scale without sacrificing too much of the other twos? In Ethereum, we are dealing with some different bottlenecks. So there are different reasons why it's difficult to scale. So one of the things about Ethereum is that we want to, like Peter was talking about, we would like Ethereum to run on a toaster. That's not always possible, but at least idealistically, that's what we would like. But in order to achieve that, we cannot allow, for example, that the storage requirement for a node grows too big or too fast. And that's one of the bottlenecks that we deal with. There's also just compute, how much CPU a node has to take, and thus bandwidth and so on. But low-hanging fruit for us for quite a while has been the storage. So right now, an node takes up about 1.5 terabytes of storage. And we have always, for a very, very long time at least, had this idea that we would like nodes to remain below the 2 terabytes, because generally speaking, when you buy storage medium, it comes in 1 terabyte, 2 terabyte, 4 terabyte. So there's like a jump in hardware requirements if you go over this 2 terabyte limit. And after a long time, and probably too long time, we have finally committed to actually getting rid of a lot of what we call historical data. So this data is basically data that a node doesn't need. There's no point for a node to have this data other than the historical purposes of being able to basically replay the whole chain from Genesis. So a node runs perfectly fine without the data. It doesn't need it at all. But there's also this, you can say, it's kind of a nice value or feature that you are able to replay the entire blockchain from Genesis all the way to current state. And for that, you need the historical data. So it's not that the historical data is not important, it's just that we don't need to store it, or at least it's not an optimal solution to store the historical data on a node. So basically the solution that we've been working on for some time now, it's called Portal Network. But then Thomas, my former CEO, he kind of threw a wrench in the wheel, and actually the Portal team got axed. They were all fired. So right now we kind of have to figure out a way to make Portal still work and get rid of this historical data. But we are committed to it, and we are going to do it. So this graph is basically just displaying how much storage a node takes today. So today it's about 1.5, but if we take away all the historical state or historical data, we're going to save up to around terabytes. So that means a node goes from 1.5 to 512 gigabytes, approximately. That's really good, because that actually gives us plenty of room to then turn up the gas. Because one of the issues with turning up the gas is that the state size and the storage requirements is going to grow faster, basically. So one of the initiatives is get rid of the historical state. And then we have a bunch of ERPs coming, which optimizes the L1 gas, which again enables us to turn up the gas even more. And that means that we already turned up from 30 to 36, and by end of year, we hope to have it hit 100 million gas. So that's like a 3x increase performance just on the L1. And then by 27, we hope to have increased the L1 gas by 10x. But that will require that we actually implement all these initiatives. It's a bit technical, but basically all these ERPs are there to optimize the performance on the L1. And without increasing hardware requirements, we can actually increase gas up to 10x. And it's reasonably low-hanging fruit. We're pretty confident in it. And most importantly, we are committed to it. It's just that we're not so good at actually telling people that this is what we're doing. But it is coming. We are committed. So I think it's pretty good already. I mean, it's end of year, 3x. That's pretty good, right? 3x scaling? Come on. No? All right, so that's the L1. So what about these rollups then? So basically, the idea is we make them based and we make them native. Okay, so right now we have this problem with the rollups being their own central isolated islands. They cannot communicate with each other. They cannot compose. You cannot make cross rollup transactions. So what's the solution? So our solution, or what we propose, is basically we make them based. And what this means is that instead of having centralized sequences, which is how most rollups basically work today, where you have a central server picking up all the transactions, sequencing them, and then posting the block. Instead, we're going to sequence these blocks from the L1. And if a rollup is based, it sequences on the L1, and by having this shared sequence layer, all the based rollups are then able to compose with each other, creating cross rollup transactions and eliminating this isolation that we're currently facing in the rollup ecosystem. And then what about native then? So I was talking about this problem with the security councils and all this added infrastructure that basically a rollup needs today. Primarily because a rollup wants to be EVM compatible, or most rollups do, but EVM evolves over time. So if it evolves over time, then you need to upgrade. So what's the idea behind native? Well, basically, we want to make it possible for a rollup to kind of basically, we are exposing the EVM to the outside. So a rollup is able to execute its transactions using the actual EVM, not just a virtual one day at the basically all rollups today, they have a version of the EVM that they made themselves. But the idea here is we are exposing the actual EVM to the rollup itself, and therefore eliminating the need to roll your own EVM. You just use the layer 1 EVM instead. So this has quite a few benefits. You get rid of all this trusted infrastructure you no longer need. It is way cheaper, actually, because now you don't have to roll your own EVM. Also, there's potential for a lot of bugs when you roll your own EVM. One example was Optimism had a bug that basically allowed for infinite printing of tokens, and anyone could do that. And that was caught very shortly before they went live. So it has multiple benefits. Basically, what we want to achieve by this is we remove all the trust elements. We make rollups composable using the layer 1. We make it much more secure, and therefore kind of fulfilling the original promise of rollups, which was that they were supposed to inherit the security of the L1. And you could say today that might not entirely be true. But with these initiatives, we are definitely on the right way. All right, and then I also want to talk about a little bit about a thing that happened quite recently. So we mentioned zk technology before. So just a briefer. zk basically is a way that you can verify a piece of calculation in constant time and without knowing all the inputs. So you can do a calculation. It doesn't actually matter how big the calculation is. Then you compute a proof, and this proof can be verified in constant time. And this is quite important because it means that if you separate compute from validation time, you can basically put as much compute in as you want. And what happened quite recently is that this company called Succinct was able to do real-time proving of an Ethereum block, meaning that they could prove a block using zk in less than 12 seconds. And that's very important that it's less than 12 seconds because it unlocks something very, very, very significant. Because then you can prove an Ethereum block in real time, meaning that you get something, you get the possibility of real-time settlement. You get what we call synchronous composability, meaning that now you can actually real-time settle across rollups any transactions. So you can make these super transactions that are able to, for example, provide liquidity from Optimism to zkSync or whatever, because there was some arbitrage inefficiency on Uniswap or whatever. You can bridge tokens and so on and so forth. And you can do this all in a single block because of real-time proving. So if you are in a stage like that, that basically means that the chain abstraction that we've been talking about for a while actually becomes a reality. So you know this very annoying thing in MetaMask when you click the drop-down and then you go from mainnet to Optimism and zkSync and some strange thing maybe you added at some point and you don't really know what's going on, and then suddenly you transferred tokens on Optimism instead of on mainnet. Maybe you're not even aware of it. And basically, if we get to this stage, we get to proper chain abstraction world where we no longer have to have this drop down. And all of this stuff can basically rollups, mainnet becomes the same thing. It's just a technical detail that can be abstracted away in your wallets. You don't have to care about it any longer. You can just have searchers who searches for the most optimal path from the most optimal use of your transaction, which network to use, and so on. And I had a bit of a fun with an AI making this video here. So I know it's a bit weird concept, zk stuff and real-time proving. It's not so easy for non-technical people to understand, but basically the idea is you have this zk prover who runs on some quite sophisticated hardware, able to take all these transactions, compute a proof, post it in a block, distribute it across the network, just as you would normally. The proof gets validated, and the validators can validate the proof in constant time, so it doesn't matter how much this prover actually computed. He can prove, or he could have computed 10 gigagas or 1,000 gigagas, whatever, it doesn't really matter. So that means that in the future, we are going to get end of year 3x L1. We're going to get PDAS as well, boosting blobs capacity. And my prediction is that by 26, 27, we're probably going to make it up to 300 million gas. We're going to see the first native rollups. zk rollups will also start real-time proving. And by 28, we might start seeing some native zk rollups implemented on L1, being able to have some pretty significant TPS. And also, at that point, chain abstraction can become a real thing. So all these native zkEVMs using real-time proving, basically they can use chain abstraction in a way where you no longer care which rollup you're on. And then in the far future, when the L1 itself becomes a zkEVM, basically we just make the L1 a zkEVM using the exact same principles. And at that point, the sky is the limit. All right, thank you very much.
Thank you so much for that. We have quite a few questions. Thank you so much for all the insightful questions. Can we try to answer them as succinctly as possible, so we can try to go through as many as we can? Can you please scroll up? Yeah. Why is Ethereum Foundation optimizing for 1 gigagas, one that eliminates solo stakers and make L2 obsolete?
No. So what I said was we were aiming for 100 million gas. So that's only a 3x end of year. Gigagas, that's way out in the future. We probably need something like zkEVM for that. But end of year, 100 million gas. This is possible because we're going to drop all this history. So that frees up all this storage for us. And then in Fusaka, it's not really decided yet. But we have these initiatives, again, that optimizes the L1. And we are ensuring that we are not compromising decentralization or solo stakers at all. So the node software or the node hardware that runs today will work exactly the same. It's all happening because we make these optimizations and because we are getting rid of this historical data that we no longer need, basically.
Thanks. If we enshrine a native zkEVM at L1, does it mean the other rollup architecture become obsolete or second-hand eventually?
No, because it's still very valuable for a rollup to be able to basically create their own blockchain. So it's their own little network. They can set the parameters the way they want. They can do zkEVM that with a way larger scale, or with special, like they can do like, they can decide that on their network you will pay gas with their native token, or whatever. There's going to be a lot of value in like being able to decide and design your own network or rollup the way you want it. So there'll be plenty of space for L2s and rollups, even in the event of the L1 becoming zkEVM.
What does Ethereum need for quantum resistance?
So that's a good question. That's also something we're working on. We're not really sure yet, but there's a lot of research going into this. I mean, we are aware of it. We are working on it, but at some point we're going to have to basically hard fork and then update our signature schemes. Exactly how that will look and how that will work is to be determined, but we are working on it.
Maintaining a client team is expensive. What are some of the suitable models for EL and CL?
Not sure I get that. What are some of the sustained models?
Suitable model for EL and
okay. Right, yeah.
I think it might be beneficial to explain what ELs are and CLs. I personally don't know.
Yeah, so that's short for execution layer and consensus layer. So in Ethereum we separated after the merge the execution and consensus layer. So in Ethereum we operate with actually two clients. And in order to operate a node, you need those two clients running. And the question is getting at that it's coming back to this basically Ethereum is like a public good, and how in the world are you going to actually fund a public good that anybody can use, and there's no like I mean, how are you going to sell an Ethereum client to someone? It's basically just a public good, right? So we have the EL or EF, who has been funding Ethereum development since, of course, since he started the chain. And they funded Go Ethereum, the original client, and they're also funding, basically giving grants out to all the client teams today. But is it a sustainable model? Maybe not. There was actually a huge amount of controversy with Geth, because EF wanted to actually take Geth out of the EF and make them a separate entity, so EF could be more creatively neutral and not have like this internal client team that sort of has like a first citizen status in the Ethereum community. Yeah, I'm not sure I have a good answer to what a sustainable model is. But what Nethermind is doing is they're getting revenue streams from other sources because they have to. And basically all the client teams have to do that in order to fund the development. I'm not sure how else to do it.
Thank you. Thank you for that. We have 2 more questions and 3 more minutes. So L2 interop is a big problem in the Ethereum space from protocol level. What are some of the things that core developers can do?
Right. So like I was mentioning, we have these based rollups, which is at least a way to better compose amongst the L2s, which can be done right now. Now, based rollups then have their own problems and issues, So it's not like a perfect solution, but at least it's there. And in terms of what we as developers can do, well, we can, for example, help rollups by doing things like making it possible to become native and exposing the EVM like I was talking about before. So it becomes much easier for rollups to, well, just deploy a rollup basically, but also that you don't have all this extra infrastructure. And generally, I would like to see a lot more focus on making Ethereum a more rollup-friendly environment and making it easier, because yeah, there are quite a few problems. But like I said, we are working on it and we're trying to make it better.
Thank you so much. That was fantastic. We don't have any more time, but please put your hands together for him and the Ethereum Foundation. Thank you so much.